This is Algebra 2, Lesson 4-7, the quadratic formula. Another way to solve a quadratic equation of ax squared plus bx plus c equals 0 is by completing the square and then factoring it. Let's take the equation ax squared plus bx plus c. Let's have that equal 0. Remember, the first term, when you're going to complete the square, the a term has to be 1. So the first thing we have to do here is get rid of that a, so we have to divide everything by a. So if I divide everything by a, I'll divide this by a, divide this by a, divide this by a, and obviously divide 0 by a, and I will get 0 because anything multiplied by 0 is still 0. So here we're going to get x squared plus b over ax plus c over a equals 0. Now I'm going to move that c over a over to the other side because if we're going to complete the square, we have to move that over. So we're going to have x squared plus b over ax equals negative c over a. Now to complete the square, we have to take our b term, which is b over a. Okay. Remember, you take b over a, and you divide it by 2, so we're going to multiply by 1/2. So that becomes b over 2a. And then you square it, so b over 2a, quantity squared is going to become b squared over 4a squared. So we're going to add b squared over 4a squared to both sides. Okay, so we have x squared plus b over ax plus b squared over 4a squared equals negative c over a minus, let's make plus because we're adding it to both sides, plus b squared over 4a squared. So it looks kind of weird right now, but don't worry about it. It'll kind of make sense in a second. Now we got to complete this. We got to factor now, remember. So this portion right here, always factors to what it was before you squared it. So this would factor to x plus b over 2a quantity squared. And that's going to equal, and I'm just going to change the order here because I want my first term to be positive, b squared over 4a squared minus c over a. Now what I need to do is I need to get a common denominator on my right-hand side because I have to do that before I can solve this. So I'm going to have x plus b over 2a quantity squared is going to equal, my common denominator is going to be 4a squared. Okay, so I'm going to have to multiply this by 4a and this by 4a to get 4a squared. So I'm going to have b squared minus 4ac all over 4a squared. Now, I need to take the square root of both sides because I need to solve this. So you get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared, but I can simplify that a little bit. So I'm going to have x plus b over 2a is going to equal plus or minus. The top doesn't simplify. You get the square root of b squared minus 4ac. But the bottom, the square root of 4 is 2, and the square root of a squared is a. So the last thing I need to do is solve this for x. So x equals, we're going to subtract the b over 2a. So I'm going to have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Since these are like terms, we can combine them. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula. Okay? That is the quadratic formula. Aren't you glad you don't have to derive it every time? You just need to memorize it. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that's how we derive quadratic formula. Okay? So the quadratic formula then is that, and you need to make sure you know that. That is the quadratic formula. Okay? And you can use the quadratic formula to solve any quadratic equation. Okay? Sometimes it will solve faster by using the quadratic formula. Sometimes completing the square or factoring or something of that nature might be a faster way to solve it. But it will always solve using the quadratic formula. It may not be the fastest method, but it is a 100% foolproof method. So let's use the quadratic formula to solve some equations. Whenever I use the quadratic formula to solve, I always make sure I indicate what A, B, and C are because that just makes it easier. So in this first equation of 3x squared plus 23x plus 40, A equals 3, B equals 23, C equals 40. So the equation says negative B, negative 23, plus or minus the square root of B squared, so 23 squared, minus 4 times A times C, all divided by 2 times A. And you need to memorize the formula because the faster you memorize it, the better off you'll be. Now, of course, we need to put some things in the calculator because most of us don't square things very well all by ourselves. So this would be negative 23 plus or minus the square root of 23 squared, which is 529, minus 12 times 40, which is 480, all over 6. Okay, so that's negative 23 plus or minus 529 minus 480 is the square root of 49, all over 6. So we can actually solve that because the square root of 49 is 7. So this is negative 23 plus or minus 7 all over 6. So to solve this, x would equal negative 23 plus 7 over 6, and x would equal negative 23 minus 7 over 6. So negative 23 plus 7 is 16 over 6, which would reduce to 8 over 3. And then negative 23 minus 7 is negative 30 over 6, which is negative 5. So there's your two solutions for that particular quadratic equation. You have negative 8 thirds and negative 5. And it's just a matter of plugging it in to make sure you work out all the pieces. Sometimes they end up to be numbers that are pretty easy to solve. Sometimes they don't end up to be rational numbers. They can end up to be irrational numbers. Let's take a look at problem number 2 for a moment. Scroll all the way back up here. Problem number 2, I'm going to do in green. So well, first of all, before I can even do this, I need to make sure that I get it in the right form, which is equal to 0, which is not. So 5x squared here. 5x squared minus 2x minus 2 equals 0. Otherwise, you're going to get the wrong sign on your C term, and you're going to mess up the entire equation. So A here is 5, B is negative 2, and C is negative 2. So negative B, negative 2 is 2, plus or minus the square root of B squared, negative 2, quantity squared, minus 4 times A times C, all divided by 2A. So 2 plus or minus the square root of 4 plus 40, because you're going to have negative and a negative, which is going to be a positive. 4 times 5 is 20, 20 times 2 is 40, all over 10. So 2 plus or minus the square root of 44, all over 10. But the square root of 44 can at least simplify some. Okay. Square root of 44 is 4 times 11. And remember, 44 is 4 times 11, and 4 is 2 times 2. So it's 2 square roots of 11. So this would be 2 plus or minus 2 square roots of 11 all over 10. Now, let's take a look at something very, very important here. If you look at these three numbers right here, this number here, and that number there, they're all even. They're all numbers that are divisible by 2. So we can simplify this particular quadratic equation. You couldn't simplify it unless you can simplify all three. You have to be able to simplify everything outside of square roots. And I can divide each one of those by 2. So this would simplify to become 1 plus or minus 1 square root of 11 all over 5. And that's actually two answers, 1 plus the square root of 11 over 5, and then 1 minus the square root of 11 all over 5. I just prefer to write it as 1 plus minus the square root of 11 all over 5. The last one over here to the right, we'll do that one in blue. It's already written in the correct form. So A is 1, B is 4, C is negative 3. So if I do this quadratic formula, negative B, negative 4 plus or minus the square root of 4 squared minus 2 times A times C, all divided by 2A. Okay. That's 4A, see? Excuse me. I knew I messed that up somehow. Here, go back here. Okay. Negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. So we're going to have negative 4 plus or minus the square root of 16 plus 12, because minus a minus, all over 2. So negative 4 plus or minus the square root of 16 plus 12 is 28. Okay, all over 2. 28 should reduce. 7 times 4. So 28 is 4 times 7, and 4 breaks down to 2 times 2, so it's 2 square roots of 7, so negative 4 plus or minus 2 square roots of 7, all over 2. And again, if you're paying attention, okay, if you're paying attention, this number here, and this number here can all reduce by 2, so I get negative 2 plus or minus the square root of 7 all over 1, or negative 2 plus or minus the square root of 7, because they all reduce. So that's using the quadratic formula to solve. Notice you'd never be able to factor that because you're not going to be able to factor something with a square root. So you wouldn't have been able to factor that. You could have factored the first problem, perhaps. Not the second problem, and definitely not the third problem. Okay, let's take a look at applying the quadratic formula. Okay. Application of the quadratic formula. Let's just say you sell wrapping paper as a charity fundraiser. The equation P equals negative 6x squared plus 280x minus 1200 models the total profit P as a function of the price X per roll of paper. What is the smallest amount in dollars you can charge per roll of wrapping paper to still make a profit of $1,500? In other words, you don't want to charge too much money because people won't buy the wrapping paper, but you need to earn $1,500 on your wrapping paper fundraiser. So, remember, the quadratic formula is the following. It says y equals, or x equals, okay, it doesn't really matter, I'm going to put it as x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so we want to know what's the smallest amount of money we can charge and still make a $1,500 profit. So $1,500 then gets plugged into X because that's what we want to make. We want to make the total profit as a function of the number of rolls. So 1,500 is going to equal, right, negative 6x squared plus 280x minus 1,200. So now we have it in our equation. So we need to solve for x. So if we're going to solve this equation, the first thing we need to do is we need to subtract the 1,500. So that's going to give us negative 6x squared plus 280x minus 2,700. So A is negative 6, B is 280, and C is negative 2,700. Yeah, very big numbers, which is a lot easier to put in the quadratic equation than it is to just try to do by yourself. So we put this in the quadratic equation, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Right? If we plug all that in, you're going to get negative 280 plus or minus, and I'm just going to do this really fast. Okay. If I hit 280 squared, 280 squared, and I'm going to add, because a negative and a negative is a positive, plus 4 times 6 times 2,700, and that's going to give me, so if I have, I have two negative signs here, so either 280 squared minus 4 times 6 times 2,700, 4 times 6 times 2,700, and I'm going to get 13,600, all divided by negative 12. Right, so simplify that as far as we can go. We actually don't even need to simplify that as far as we can go simplified ways. We just need to work it out mathematically. So I'm going to do negative 280 plus the square root of 13,600, all divided by negative 12. And I'm going to stick that in my calculator. So negative 280 plus the square root of 13,600, divide that by negative 12, and I'm going to get approximately 13.615. Then if I take negative 280 and I subtract the square root of 13,600, divide that by negative 12, that's going to give me negative 280 subtract the square root of 13,600, and divide that by negative 12, and I'm going to get 33.05. So the smallest amount I can charge and still make a profit of $1,500 looks like it's going to be about $13.62 per roll. Okay, so there we go. If I charge the maximum amount of $33.05, I could probably sell less rolls, but I don't know too many people that are going to buy a roll of wrapping paper for $33 a roll. Okay. All right, let's move on. A quadratic equation can have two real solutions, like x squared equals 4, so you're going to get x equals plus 2 or minus 2. One real solution, like x squared equals 0, so x is going to equal 0. Or no real solutions, x squared equals negative 4, because you don't know what the square root of a negative number is yet. You will soon. In the quadratic formula, the value under the radical symbol, b squared minus 4ac, tells you how many real number solutions exist. Real number solutions. Okay? So that's called the discriminant. The discriminant of a quadratic equation in the form of ax squared plus bx plus c equals 0 is the value of b squared minus 4ac. Just what's underneath the square root. Just the b squared minus 4ac. You don't even have to take the square root of it. If you look at this table below that I have actually printed out in your notes, the table below shows the relationship among the values of the discriminant and the solutions of a quadratic equation and the graph of the related function. So if b squared minus 4ac is greater than 0, like if you take b squared minus 4ac and you get a number like 12, you will have two real solutions, which means you'll have a parabola that crosses your x-axis in two spots, either opening upward or opening downward. If b squared minus 4ac equals 0, you will get one real solution, which means your vertex is a number and it's on the x-axis. So it's going to be something and 0, like 30 or 40 or negative 40 or something like that. And it's going to open upwards or downwards. You're going to only have one solution because it's going to cross the x-axis in one spot, and that's at the vertex. If you get b squared minus 4ac equals 0, you're going to get no real solutions, or no real solutions, otherwise known as two imaginary solutions, which means it never crosses the x-axis. Your graph will never cross the x-axis, giving you no solutions. And we'll understand more about imaginary number solutions when we get into 4-8. So let's look at something. We're just going to determine the type and the number of solutions given the following equation. So if I have the equation 2x squared minus 3x plus 7 equals 0, I'm just going to do the b squared minus 4ac part. Okay, so a equals 2, b equals negative 3, and c equals 7. So b squared is negative 3 squared minus 4 times 2 times 7. So 9 minus 4 times 2 is 8, 8 times 7 is 56. So I'm going to get a negative number, aren't I? Okay, I'm going to get negative 47. Okay, It's a negative number, so b squared minus 4ac is less than 0, which means I am going to get no real solutions. Okay, otherwise known as two imaginary solutions. Okay, two imaginary solutions. So 47 is the value of my discriminant, and the number of solutions I have is no real, otherwise known as two imaginary. If I have the equation negative x squared plus 14x equals 49, first thing I need to do is make sure I know a equals negative 1, b equals 14, c equals negative 49, because we need to move it to this side of the equation. So in b squared minus 4ac, 14 squared minus 4 times negative 1 times negative 49. Okay, 14 squared is 196 minus 49, negative 49 times negative 1 is positive 49 times 4 is 196. So 196 minus 196 is 0, so I'll have one real solution. Okay. If b squared minus 4ac is less than 0, two imaginary solutions. B squared minus 4ac equals 0, one real. B squared minus 4ac is greater than 0, two real. Last thing here, we're going to use the discriminant to solve a problem. Okay. This is a typical type of physics type problems that you'll see when you take physics, if you take physics next year or the year after. A rocket is launched from the ground with an initial velocity of 150 feet per second. The function h equals negative 16t squared plus 150t models the height in feet of the rocket at time t in seconds. Will the rocket reach a height of 300 feet? And explain. Okay, so we want to know in the formula h equals negative 16t squared plus 150t, will my rocket reach a height of 300 feet? So to do that, we want to know, is it going to reach 300? So we're going to put 300 in there, negative 16t squared plus 150t. Let's put this in the right form, so negative 16t squared plus 150t minus 300 equals 0. So we subtracted 300 and moved it to the other side of the equation. Okay, now we're just going to use the discriminant to figure out how many solutions we're going to have. So a equals negative 16, b equals 150, c equals negative 300. So b squared minus 4ac, 150 squared minus 4 times a, which is negative 16, times c, which is negative 300. Okay. 150 squared is 22,500 minus 4 times negative 16 times negative 300 is 19,200. 22,500 minus 19,200 is 3,300. Okay, so the question asks, will the rocket reach a height of 300 feet? Okay, the discriminant is positive, so there are two real number solutions for when that rocket will hit 300 feet, because obviously here we solved for t. If we plug in t in this equation, we're going to get two different answers. We have the discriminant being 3,300. Okay, so if my discriminant is 3,300, I have two real solutions. So yes, the rocket will reach a height of 300, will reach a height of 300, I think it was meters, I'm not sure. Meters or feet, let's say 300 feet. Okay. Okay. So there's two positive solutions. There are two real solutions for a time t when the rocket's height is 300 feet. So in other words, you're looking at a parabola that looks like this, and perhaps that 300 feet is here and here. So there are two spots in which that rocket will be at a height of 300 feet. Once on the upward, and then once back on the downward. And this is the quadratic formula.